start this recording here. Okay, so I've got a couple of copies of the practice test. Did anyone not get the practice tests yet? Pardon? Yeah.
Like it's due.
Oh yeah, but we're gonna go through it, so. If anyone doesn't have one, you can come grab one here. Okay. So, everyone was able to, well, besides those who came up and showed me their work, you were able to scan your work and put it on Moodle, and then I can look at it later. The idea was to save some time here, which I think we did. Okay, so, oh, I was showing you on Moodle, I posted the short answer solutions. Yeah, sir.
I wasn't able to scan it. I just take pictures and make a presentation out of it.
Oh, and you uploaded that? That's great. Yeah, yeah. As long as you found a solution to giving me your work, then that's great. Yeah. Good idea. So I posted the short answer solutions. The reason I'm not going to spend a whole lot of time on, well, I won't spend any time on the short answers, is because I gave you those short answers as to give you an idea of the length more than the idea, like the exact types of questions, whereas the long answers, those are the questions that you can expect to see. And so for the short answers, right, you're just calculating quick little future values, present values, R's, T's, N's, right? So just like quick little calculations. So you still have to practice everything, not just the practice test for the short answer, right? And it just looks like this. And I've just highlighted really the only thing that you need to give me, oh, the days between dates. Yeah, for full answers. But if you get it wrong, if you've shown work on the test, then I can give you part marks, right? So yeah, you can gamble and just give me the answer, or if you show your work, then I can give you part marks if it's wrong. Okay, so that's about it for the short answer. So today we're just going to work through the long answer solutions, and then that'll be good. All right. Let's see here. So I've got the practice test here. I'll just steal all of this. I've got this note on here in the first blurb for the long answer, right? For your long answer problems, you have to show all your work and your timelines. But on the test, I've actually moved this stuff to the front of the test, right? So it's not going to be there, but it's going to have all the information that you need. So if you use your financial calculator, find an answer, be sure to list all the pieces of information. And here the list cuts off, but on the test, I've actually given you the entire list of things that you have to tell me, right? And that's how you get marks if you're doing it just on your calculator, right? Which we showed last day was a little bit easier, maybe a lot easier than doing it by hand, right? And you're welcome to do that, except for the last long answer question, you have to do by hand. Okay. So, all right. Rocky and Adrian have become real estate agents. Great. They're selling their house and received 2 offers. We've seen problems like this before, right? You've seen, I think in the Moodle quiz, you've seen a question like this. We've done one in class together. And so we've seen questions like this before. And so we've got 2 offers and we have to compare the offers. What are they worth today? and then we can compare them and pick the best one. So the first one has a total of 450,000 paid, with 50,000 down. So a down payment today of 50,000, and then 2 payments of 200,000 after 2 and 4 years. The second offer is 475,000 total paid, where they're only paying 25,000 down today, and 1 payment of 450,000 after 3 years. Assuming a 6% rate of simple interest, that's going to be an important thing to keep track of, right? Because on this test, on test 2, there's going to be simple interest problems and compound interest problems, right? Which you probably noticed on the practice test. But that's all we're dealing with, right? Simple interest, compound interest. And so it's really focused, but for each question, we have to keep track of, do we have simple interest or do we have compound interest, right? Because that's going to tell you where on the formula sheet are you getting your formulas from. And so this is a simple interest problem. Which offer should Rocky and Adrian choose? Justify your answer, include a timeline in your answer, and use today as the focal date. I'll highlight that as well. So what I'm going to do is I'm going to figure out what each of them are worth individually. Right, so I'm going to do offer number 1, and then I'm going to do offer number 2. Just because how I like my timelines, and you don't have to, I'm going to put all of the dates that I need on here on the same timeline, because then I can kind of look at it overall. And so we need a tick for today on our timeline. Right? And then we've got a payment at 2 years, a payment at 4 years, and then in option number 2, we have a payment at 3 years. Right? And so, make sure I'm recording here. Yeah. For my timeline, I say 4 things. Put 4 ticks on there. Start today. And then the next tick was at 2 years. This one's at 3 years. And this one's at 4 years. And that's just because I don't want to put that effort into figuring out how many ticks and stuff for my second timeline. Now I just know that that's the exact same one that I'll use for my second offer as well. In this first offer, we have 50,000 down. So I'm going to put, that means 50,000 today. And 2 payments of 200,000 at 2 years, and 1 at 4 years. Good. Today as the focal date is really just saying, what's the value today? So your focal date is the date that you're going to draw all your calculations to, right? And so that means that this 200,000 at 2 years is going to get pulled back. And when we're pulling back the arrow, we're going to calculate some present value 1 or P1. And I just use the subscripts to denote the order of my calculations. Right? And then the 200,000 at 4 years has to get pulled back as well to some P2. If I add these all up, 50,000 plus P1 plus P2, that's the total value of offer number 1 today. And so total value of offer number 1 today, if I add those up. on these arrows, right? For simple interest, we just put time. Here it's nice because we're dealing in years, so we can just say T is 2 years. Between today and 2 years from now is just 2 years. And between today and 4 years is 4 years. And the rate was the same for both of these, right? 6% simple interest, so R is 0.06. All right. So we're ready to calculate these P's, but for simple interest, right, we only have one formula, so we have to show how we get the solve for P just once though. Future value is P times 1 plus RT. Solving for P, we know P is the future value over 1 plus R times T. Now that I've solved for that formula, I can use it in my calculations. And so P1 is the future value over 1 plus RT. The future value of P1 is 200,000. Right? And so just remember that whatever is on the left-hand side of the arrow, right, or yeah, any arrow, is the present value or the principal amount, and whatever's on the right-hand side is the future value. So if the arrow is going to the right, you're calculating a future value. If the arrow is going to the left, like here, then you're calculating a present value. And so it just depends on how the arrow is going. And that's why I have to tell you what to use as the focal date, right? So you know where to pull your arrows to. So P1 has a future value of 200,000 over 1 plus R, which is 0.06. And T for P1 is 2 years. So we get 0.06 times 2 plus 1. So we have 200,000 divided by 1.12. $178,571.4286, which in money is 178,571.43. So them offering to pay 200,000 2 years from today is the same as them offering 178,571.43 today. So now we do the same thing for the one 4 years from now. So P2 is the future value over 1 plus R times T. Future value for this one is also 200,000 over 1 plus 0.06. And remember, T for this one changes. It's 4, right? The length of the arrow is 4 years. So 0.06 times 4 plus 1. 200,000 divided by 1.24. $161,290.3226, or in money, 161,290.32. So now we know the total value of offer number 1 today is the 50,000 that they're offering to pay today, right? 50,000 today is just worth 50,000 today, plus 178 plus 161 ish. So the total value of offer number 1 today is 50,000 plus P1 plus P2, which is 50,000 plus 178,571.43 plus 161, 290.32 plus 178,571.43 plus 161, 290.32. I get a total of 389,861.75. Is that what you guys got? Nice. That is good news. Yeah. Offer number 2. Same deal. Only one payment though. Oops. Offer number 2. So like I said, I'm just going to recycle this timeline where I had today, and then I had 2 years, and then I had 3 years, and 4 years. Right. But offer number 2, I'll just steal it from here because it's a lot of scrolling, had 25,000 down, so 25,000 today, and just one payment of 450,000 3 years from today. Right. So to find the total value of offer number 2 today, we just have to pull back and find, I'll call it P3. The time on this arrow is 3 years, and R is still 0.06. 25,000 plus P3 is the total value of offer number 2 today. So I'm just going to jump right in and say P3 is the future value over 1 plus R times T. The future value of this one is 450,000. So 450,000 over 1 plus R, which is 0.06 still, times T, which is 3 in this case. So we get 450,000 divided by 1.1, oops, 8. Which is 381,355.9322, which in money is 381,355.93. We said, well, if we add 25,000 to the 381,000, that's the total value of offer number 2. So total value of offer number 2 is 25,000 plus P3, which is 25,000 plus 381, 355.93. And get 406, 355.93. Looks good. So now, offer number 1 was worth 389,000-ish, whereas offer number 2 is worth 406,000. I think we would choose offer number 2. Okay. Therefore, offer number 2, and that's better, is the better choice. And just for fun, 406,355.93 minus, just to see what the difference is, 389,861.75. 16,494.18 more. So it's not actually, right? Because if you look at the initial dollar amounts, right? Offer number 1 had a total value of 450,000 and offer number 2 had a total value of 475,000. But when it boils down to it, it's not actually worth 25,000 more. It's only worth 16,000 more. Right? And sometimes, depending on how these payments are laid out, sometimes the one that's worth less is actually worth more today. So you have to keep an eye out for that. Any questions about that one? Oh, that's pretty good. Oh, on here, I should tell you, so on the test and on here, it just tells you the amount of marks. So each of these long answers are 10 marks each. And I think even the short answers, a total of 20-ish marks. Here's a typo. You're saving for a trip to Mexico. I guess you could save for a trip in Mexico, but that just means that you're in Mexico and you're saving to go somewhere else. That's not really what I'm saying. So, for this one, you're saving for a trip to Mexico and you decide you need $3,000 in 3 years, right? So you set some savings goal for yourself and you decide to budget ahead by making 2 equal payments, right? So unknown equal payments, one now and one in 2 years from now. Assuming an interest rate of 5% compounded weekly, that's what tells us that we have a compound interest problem, right? Because I'm telling you the interest rate is being compounded. Sounds silly, but sometimes you just need to point that out. What are your equal payments? Use a focal date of 3 years from today and include a timeline in your answer. You got it. So for our timeline, right, we have to figure out what dates we need to put on there. We have to have today, right, as a reference point. And then we need a payment today and a payment in 2 years, and then we need the total to be 3,000 in 3 years, right? So I'm seeing 3 ticks here. We'll just do that. So today, and then at 2 years, and then at 3 years. I spaced them equally just because we only use the timeline to visualize things. Nice to have them spaced out. All right. How do we deal with these unknown payments? For the unknown payments, we just put X on our timeline, right, as the amount, and then we solve for X. So here, we're going to make an unknown payment today, right, starting today, one now and one in 2 years. These values, right, we're told to use a focal date of 3 years, but actually, there's no other option, right, because we know that these two payments have to total $3,000 at the end of 3 years, right? So here, there's no other real option for a focal date, right? So we're gonna pull this X. We're pulling it forward, so we're calculating a future value, call it future value 1. And then we're gonna pull this forward as well, call it future value 2. And then we're saying, well, no matter what, these have to equal $3,000. Okay. So when we're solving for unknown payment amounts, we have to know what they total to, right? Otherwise, we can't solve for X. And so that's why we have to have them equaling 3,000. This is compound interest, and we're compounding weekly, so F must be 52. And just jotting it down here, we've got 5%, so the rate is 0.05. On the arrows for compound interest problems, we have to put N, the number of compoundings. And from your formula sheet, N is time times the frequency. Time for this first arrow, right, is the time between 2 years and 3 years. So that's just 1 year. So 1 year times a frequency of 52 is just 52. For future value 2, N is time times the frequency again, but now time is the time between today and 3 years from now, so just 3 years times 52. I don't know. 156. And we also have to include that I is R over F, which in this case is 0.05 divided by 52, which is itty bitty 1.123961538. Sorry, in the beginning I was counting zeros. This, because I'm going to need it, I'm going to store it in 1. Make a note of it, because I don't want to lose any of those decimal places. Okay, so here I'll just try to highlight that everything you see here has to be included for a complete timeline. For this one, I don't think you can use your calculator just because we have to have them adding up to 3,000. I don't know how you would use your calculator. I'm sure it can, but I don't know how. So we have to do it by hand. So we know that x is going to turn into future value 1, and then the other x is going to turn into future value 2. So we're calculating future value 1 from our formula sheet. Now remember, you have compound interest, and so the future value is just the, well, I'm trying to show you on here, but it's not very helpful, is the present value times 1 plus I to the power of n. The present value of future value 1 is just x times 1 plus I, which is 0.000961538, to the power of n, which for future value 1 is 52. It's actually easier if you just do all this work on your calculator, solve it without showing any steps in between. You can, but I'm also saying you don't have to. So I've got 0.00961 on my calculator plus 1 to the power of 52. So now I have 1.051245842 times x. I'm going to store this in 2, just because I'll need it later. Same deal, I can calculate future value 2 is the present value times 1 plus I to the power of n. Present value again is x times 1 plus I, which is that 0.000961538 to the power of 156. 1 plus recall 1 to the power of 156. Get 1.161750513 times x. I'll store that in 3 just in case. So what we said was that, okay, future value 1 plus future value 2, whatever they are, they have to total 3,000 3 years from now. And so we know, we know that future value 1, or actually I'm going to start with the 3,000. 3,000 has to equal future value 1 plus future value 2. Future value 1 is 1.051245842 times x plus future value 2, which is 1.16170513 times x. Those have to equal 3,000. We've got something times x plus something times x. So we can just add those up. And that's why I stored them on my calculator, plus recall 2. So I get 212996355 times x has to equal 3,000. So now x must be 3,000 divided by 2.212996355. So X must be 1,355.62808. In money, 1,355.63. So each payment, right? One payment today and then one payment 2 years from today of $1,355.63 is going to total $3,000 in 3 years from today. So that's your answer. How could this question change pretty easily? Well, thinking about your timeline here, right? Here we're saving for some amount. What if you had taken out a loan today and you had to repay it with 2 payments, maybe even 3 payments, who knows, right? But solve for those unequal payments. It works the same way. It's just that now you have to pay off the loan what it's worth today, right? And so you'd be calculating present values instead of future values. But that's really the only difference. So, easy way for it to change. Otherwise, no, it'll just be either the arrows are going to the future value or they're going to the present value. Any questions about that one? Oh. So for question, I guess 4, oops. Oops. All right. So for question 4, a contract requires payments of $5,000 and $7,000 made in 2 and 6 years respectively. Okay. What 2 equal payments made today and 4 years from today are equal in value to the original contract? Assume that money earns 3% compounded, right? So you have a compound interest problem, again, bi-weekly. I haven't given you a focal val or a focal date, but how about we use use 4 years from today as your focal date. It actually doesn't matter. So if you went through and you did something else, it's not going to matter. But I'm just telling you to use it now in case you're just following along. Okay. On the test, I'll make sure to tell you what to use as the focal date. But what you'll notice is it actually doesn't matter. Because what you're just forcing is that, okay, once you picked your focal date, all these payments, you're going to figure out what they're worth on that date, make sure they're equal, and then that's it. And so here, I'll just put a little star there. So this is one of those situations where we have an original payment scheme, right? And then we want to figure out, okay, what's an alternative payment scheme that's worth the same? right? So equivalent payments. So let's figure out how many dates we have on our timeline, and then we'll go from there. So we've got 2 years and 6 years from today, but that means we have to have today on there, right, just as a reference point. And then what 2 equal payments are made today? Today is already on my list, and 4 years from today. So I have 4 points on my timeline. I've got today, I've got 2 years, 4 years, and 6 years. And how I'm gonna draw this, and if you wanted to, you could put them all on the same timeline, but as you'll notice, it gets a little messy. And so I'm gonna make up the original payment scheme timeline and then the new payment scheme timeline. So here's my original payments. It didn't leave myself much room. And I'm saying here's our focal date that I've picked. You might have picked a different one. That doesn't matter. So we've got a payment of $5,000 2 years from now and $7,000 6 years from now. So if we're using 4 years from today as our focal date, that means that we have to draw these payments and see what they're worth 4 years from today. So the order here doesn't matter, but I'm gonna pull the 5,000 to a future value 1 and pull the 7,000 back to some present value 2, just denoting the order of my calculations. How, with the order you find these in doesn't matter. The total here is the total value of the original payments at 4 years. So this is the total value of original payments, at 4 years. You definitely could go ahead and show the calculations, figure out what that total is. But in this case, because I want to be able to show you the timelines together, I'll do the timelines one on top of the other, mixing things up. And then here's the revised payments. Using the same timeline. Today, 2 years, 4 years, and 6 years. Getting sloppy. So the new revised payments are, so what 2 equal payments made today and 4 years from today? So we've got an unknown payment today and that same amount of unknown payment at 4 years. And we've seen trickier ones than this, right? Where we had to, the second payment was double the first amount, right? Then you would have 2x, but in the end, you're still just solving for x, right? And so you've got today, and we were using 4 years as our focal date, which means we have to use 4 years as our focal date again, right? Otherwise, they wouldn't be equal. Which is nice because then we only have to pull this x forward. to some future value 3. So then x plus future value 3 is the total value of the revised payments at 4 years. So this is the total value of the revised payments at 4 years. In order for these payment plans to be equivalent, right, to be the same, these totals, we have to force them to be the same. Right? Remember we said when we were solving for unknown amounts, we said, well, we have to know what the total is, right? So this just introduces one extra step to find the total before we can solve for the unknown payments, right? Because we're gonna have to find the total of the originals at 4 years and then use that to figure out what x is. So we can do our calculations and we can say, okay, well, first one I'm going to calculate as future value 1. Yeah. There's some stuff missing on our timeline here. So let's fill that out first. If it's compounded bi-weekly, F is 26. That's a good one to remember. And then the distance of this arrow between 2 and 4 years is just 2 years, right? So you don't want to get thrown off by 2 and 4. It's the length of the arrow. So n is time times the frequency. Time here is 2 years times 26, 52. And for the next arrow is time times the frequency, between 4 and 6 years, it's another 2 years times 26, which again is 52. While I'm at it, I'm going to put the n on the revised payment arrow as well. Time times the frequency. Time between today and 4 years is 4 times 26. Wouldn't you know it? 104. Interest for both of these situations is the same, right? It's 3% compounded weekly. And so I'm going to say somewhere along here, maybe here at the bottom, I is R over F, which is 0.03 divided by 26, which is 0.001153846, which of course I'm going to store in 1. So I'll need it. Everything from here on up, that's all included in a complete timeline. So you don't want to be missing anything from there, right? Because then you could be missing marks. I don't know. I guess you could squish them all on 1 if you wanted to. But all the information has to be there. All right. We're ready to get to work. So we wanted to find future value 1. So future value 1 is the present value times 1 plus I to the power of n. The present value of future value 1 was 5,000. And just so I can remember, n is 52. 5,000 times 1 plus 0.00115386 to the power of 52. We'll just do this all in one go. Mostly because you've got the I stored in your calculator already, so it's just easy to just plug it in. So plus 1 to the power of 52 times 5,000. 5,308.999098 in money. 503 or 5,309 even. Future value, or sorry, it's not a future value, it's a present value. Present value 2 has a future value of 7,000, right? And n is still 52. And what's nice is because we have the formula for PV on your formula sheet for compound interest, you don't have to show how you find the formula. You can just use it. Future value divided by 1 plus I to the power of n. We said the future value is 7,000 over 1 plus I, which was 0.00115386 to the power of 52. So 1 plus recall 1 to the power of 52. And then I have 7,000 divided by that guy. 6,592.57976, which in money is 6,592.58. So now, what I'm going to do is I'm going to go ahead and find future value 3, just so I have all the players, right? If you wanted to go ahead and solve for the total value of the original payments, then that's fine, right? But I'm just going to go ahead and find future value 3. Future value 3 is the present value times 1 plus I to the power of n. The present value of future value 3 is x times 1 plus 0.00115386 and to the power of 104, right? Yeah. One plus recall 1 to the power of 104. I get 1.12741885.7. I'm going to store this in 2, even though I don't need I anymore, but just in case I do. Oh, times x. So now we know that future value 1 plus present value 2 has to equal x plus future value 3. Right? Otherwise, they wouldn't be equivalent. And so we've got future value 1 was 5,309.00 plus present value 2 6,592.58. 659258 is x plus 1.127418857x. Now it's just a matter of collecting like terms and simplifying and solving for x. And so we've got 1x plus 1.127, so we get 2.127418857x. 5309 plus 6592.58. It's 11,001.58. Simplifying both sides. And then finally we can solve for x, and we can say, well, then x must be 11,001.58 divided by 2.127418857 divided by I am pretty sure I did it right in my calculator, but I got 5,171.32767. Is that what you guys got? I only hesitate because I feel like I skipped a button, but it looks right. 5171.33. Just do it again. Yeah. Good. So those are your equal payments, right? One today, one 4 years from today, of 5,171.33 would be equivalent to the 5 and the 7,000. Yeah. This one? Oh. Oh boy. Well, that changes some things. Let me just see here. You're probably right. 6592.58. Haha. It was probably there all along. My eyes just played tricks on me. So what changed here? Okay, so let me just pretend nothing happened here. 11,901.58. Okay. So this is gone and this is gone. Okay. It's okay. 1 plus 3 equals 2. Looks good too. 5594. Something. Great. 5594.375533. Or in money, $5,594.38. Should, yeah. Yeah. So if you use a different focal point, the answer should be the same. And did it work? Yeah. So, but it's just for marking. It's easier if I tell you what to use, because then it's easier. Then I'll know the values that you're supposed to be getting, right? And so, but it actually doesn't matter where you put it. Right? Now that we've got the right answer on there, are there any questions about that one? No? Before, maybe there were some. Yeah. All right. Last one. This is the one that you have to do by hand, right? So you can't use your calculator. Although it hasn't really been worth using your calculator for any of these, really. The last one we did was a little bit longer, but like I said, I don't know how to use your calculator to solve it. You could use your calculator to figure out future value 1 and present value 2. That would cut down some work, right? Because we had to do that by hand, but that's not that bad. But you could use your calculator there if you wanted to. All right. All right. What's the value 3 years from now of the following payment stream using an 8% weekly compounded? So again, we have compound interest. I'll just make a note of that. And it's weekly. Weekly means that our F is 52. So we want to know what's the value 3 years from now. The 3 years from now is what's forcing that to be your focal date, right? Because I want to know what is the value 3 years from now, right? And so this is telling you that this has to be your focal date. A payment 1 year from today of 17,000 and a payment 4.5 years from today of 14,000. All calculations must be done without the help of the time value money features of your financial calculator. Yeah. And I used to have a different question on here for the test and the practice test, but I switched to this one because this one's more similar to the one that's on the final. So figured I may as well prepare you guys. So if you know how to do this one, you can do it on the test, you can do it on the final, we're all happy. All right. So we're talking about, okay, well, we want to know the value 3 years from today. And so we have a payment a year from today, but we're always referencing today, so we have to put today on the timeline as well, right? And then a payment 4.5 years from today. So I have 4 ticks on my timeline. 1, 2. So I've got today. And what's the next stopping point at 1 year? And then 3 years. And then 4.5 years. Like I said, because we want to know the value at 3 years, this has to be your focal date where you draw all your payments to. So the payment amount 1 year from today is 17,000, and a payment 4.5 years from today of 14,000. Okay, so there's nothing happening today, but we need today on there just as a reference point. So now we have to figure out what these payments are worth 3 years from today. So we draw these arrows. I'll do future value 1 and then present value 2. The total, future value 1 plus present value 2, is the value 3 years from now. Or I'll say the total value. Total value, I'll say at 3 years. Save some writing. For compound interest, right, we have to put the n on the timelines. So we have to put n is time times the frequency. Time between 1 year and 3 years is 2 years. And we've got a frequency of 52. It's not 104, but just check. And then same idea, n is the time. Time between 3 and 4.5 years is just 1.5 years. Right? And so we've got 1.5 times 52. I get 78. Yeah. And then the last thing we have to put on here is I, right? We have to calculate the periodic interest rate, and we can just sneak it off to the side here. I is R over F. R was 8%, so 0.08 divided by 52. I get I must be 0.001538462, which of course I'm going to store in 1. And then everything from here on up is making a complete timeline. Okay. So now, right, your timeline is most of the work, right? Your timeline is just organizing the information that I'm giving you and mapping out, okay, what calculations do I have to do? Once you've made your timeline, right, now it's just time to calculate future value 1 and present value 2, add them up, and that's the answer, right? So from here, it's kind of easy street. So future value 1 is the present value times 1 plus I to the power of n. Present value is 17,000 times 1 plus I, which is 0.001538462 to the power of 104. Plus 1 to the power of 104 times 17,000. We get 19,947.23213, or in money, 19,947.23. Next one, present value 2 is the future value over 1 plus I to the power of n. The future value of present value 2 is 14,000. Over 1 plus I, which is 0.001538462 to the power of 78. One plus recall 1 to the power of 78. 1 over that times 14,000. I get 12,418.03117. Check with you guys. Make sure you got the same thing. Good. So in money, 12,418.03. And so the total value 3 years from now is future value 1 plus present value 2, which is your, I have it on the screen here, 19,947.23 plus 12,418.03. 19,947.23 plus 12,418.03. Stop me if I'm wrong. I get 32,365.26. Looks reasonable. So that's the total value of the payment stream. I'm pretty sure you have one like this that's a little bit more complicated on Moodle, right? Because it's got all these payments at different time points, and then it asks you what's the value, I think 1 year from today or something. And so you have to calculate all of those and add them up, right? A little bit longer, but I've had a lot of questions about that one, so figured I'd mention it, right? But very similar to this one. So it's all good practice. Okay. Any questions about those long answer problems? No? So I've posted the short answer questions, so we're not going to go through them, but if you want, I'll be here and you can ask me questions, but otherwise I'll see you Monday for the test. Yikes.